Yeah. So good morning to all. Welcome to today's section. Is it audible? Please respond.
Yes, sir. Yes, sir.
Right. Right. Uh, Now we are going to see the another unit, angle of arrival estimation. This is very important topic in this domain. It's very important. Before going to see this topic, we'll recollect the quickly what you have discussed and what you have learned the last couple of days or from the different chapters. From the first unit, we have seen the introduction, the importance, the significance, the applications and all. Today we are enjoying means because of these features only. Even in the tough time, we are handling smoothly the online classes. Try to see the importance of this application. For timing, if this is not there, then your year is going to be wasted. Not only the academic, many online businesses, online entertainment, many things is not possible. So people are understand and recognized the importance of technology. But you have to utilize the technology in the right direction. Still, we are very poor to utilize the technology in the right direction. And we are using, but not up to the mark. We are unable to use properly. And what you are using also is a very little and not utilizing in the effectively. And we have seen the importance of the 5G communication and features. It is providing a large bandwidth. It supports the high data rate and low latency, and like that, many features we have seen. The importance of that, speed and all these things, the quality of the signal and all. And we have seen the comparisons among the all the generations. In decades back, people have struggled to get the connectivity. You ask your father or your grandfathers, they will tell their experience. To get the telephone connection, they have to wait for minimum 6 months. Minimum. Then only they'll get the connectivity. And that too, it is a fixed. If you want to make a call, you have to go there and you have to talk. But nowadays, within a fraction of seconds, through the online, you can get the instrument and you can enjoy with all the features. Those days only the voice only. And later on slowly, one by one, the features are added. Now today we are comfortable. You can talk to your parents, your friends on time without delay. This is possible with the help of these features, with this technology. Inside, so many building blocks are there. All are very, very important. From our domain, and the smart antennas are very, very essential. One of the important building block in that system, smart antennas. To improve the quality of the signal, it depends on many parameters. If we are handling properly the modulation, we can get the better signal. Or if you are going to design properly the circuit, you can get it. If you are going to apply some coding techniques, source code and channel codings and all, and you can improve to some extent the quality. And not only that, with the help of this smart antenna concepts, we can improve further the quality of the signal. Each one plays its a role, its own role. We can't neglect it. All are essential. All are very, very important. Then we have seen the importance of the smart antenna, the architecture. It is a sophisticated system. Based on its performance, we are given the name as a smart, not based on the physical appearance of the system. Normally, we'll give the smart boy or a smart girl. Normally, we are going to say that compliment based on the appearance. And then rarely we are going to say the smart guy based on his performance. And due to egos and all, we are not going to use that compliment also. But here, the smart is came based on the performance. How to achieve this the better performance? How to get a good quality of the signal? The inside we are going to processing the signal with the help of highly sophisticated signal processing block. And in that, we are going to develop some algorithms. So with the help of that, we are going to processing the signal. Then finally, we'll get the desired response. Then we have seen how to generate the multiple beams and how to control that and what is the role of the displacement between the elements and excitations, then the geometry, all these parameters we have analyzed, how it is going to be influences the radiation pattern. Then we have seen different diversity techniques angle diversity, then spatial diversity techniques, transmit diversity, all these things we have seen to improve the further the quality of the signal. And before that, one has to know the channel behavior. We have to model. We have the readily some case studies with that we can do, or we have to get the actual channel model for that problem. Then accordingly how to design. And not only that, we have seen the switched beam, fixed multiple beams concepts, and adaptive concepts. We have seen the hand-up techniques, how it is influences the and sectorization gain, what are the parameters is in, and processing gain we are seen very detailedly. And from that we got the conclusion, we have the trade-off among the parameters. If one parameter is increasing, the other is going to be affected very severely. So you have to be very careful. We have seen. And especially in a fixed mechanism, we are not utilizing all the resources effectively. Hence, we are going for the adaptive nature. So with the help of the adaptive, we are going to control and we are going to handle the problem more effectively. And we are going to adjust the main beams, side lobes, nulls, and not only that, the coverage areas and everything. Then finally we'll get the better signals. We have seen different techniques. Butler matrix, it generates based on that array. If M by M, we'll get the M beams. And from that you got it, conclusion quickly. At any instant of time, one beam is high and all other signals are nulls. Then we have seen different beamforming techniques. What do you optimal beamforming, beam steering, null steering, then minimum variance, least mean square algorithm, maximum ratio, like that, maximum ratio combining n number of beam techniques we have seen. And with that background, we are going to see today angle of arrival estimation. In the previous chapters, while using the different beamforming, we are assumed angle of arrival, then we proceeded. We tried to recollect it, the beamforming or null steering and all. And we made it at that time. Is the drawback of we need a knowledge of signal arrival directions and all in different cases. And at the time, we are assumed that we know that in which direction signals are coming. Then we have proceeded. Now, no need of assumption. We have to identify, we have to estimate in which direction signals are coming. Then, accordingly, we can handle your pattern easily. You want to steer the main beam towards 30 degrees. Why you want to steer? First, you should know that. Oh, in the 30-degree direction, the signal is coming. Or you want to radiate, as vice versa. Whether it's a transmission or reception purpose. So if you are examined, the signals are coming in the 30 direction. To receive those signals, we have to steer the main beam in that direction so that you can capture the signal easily. You are in the class. If you want to receive the maximum information from the teacher, your body should face towards the backboard or towards the teacher. Then only you'll get the effectively the information. No, I'm there in the classroom, I can turn in any direction or any angle. You can do, but you can't get the maximum information. You'll get the signal, but not effectively. Similarly here also, you will get the signal, but not effectively. So if you want to capture the signal effectively, then you have to estimate the angle of error. Then accordingly, you have to steer the beam. You have to steer the beam. You should know the importance of this. Why you want to do the angle of error. I said a number of times. Whatever you are going to learn, everything is existing in the nature. But the terminologies are different. The notations are different. But you can't map it point to point. But if you analyze your surroundings thoroughly and closely, then understanding the subject is very simple. Not only the smart antenna. Any subject is very simple. But unfortunately, our education system is not in that fashion due to many reasons. I'm not going to touch that part right now. So if you get the interest on this, then understanding is very simple. Most of the times, people are by hearting and reproducing and getting the grade. It is not correct. It is mandatory. It is essential. I'm not going to say we should not do that. The by hearting and reproducing is meant for to get the marks, not for the concept. Because the time given for the 3 hours to complete all the questions. Definitely, the by heart nature is important. Without that, it is not possible. You know the concept, but you want to deliver, you want to write everything without by heart. Even if you know the concept, it is not possible to complete the answering all the questions. Because the speed is very important. You can't analyze, you can't derive. You have to scan it and you have to print it like a Xerox machine. So that is why we need the techniques also. I'm not going to, you should not do that. But before that, you understand the concept. Then by heart, then see the happiness. And that is very important. Nowadays, that is missed. In most of the cases, in most of the students, they are not exposed. And finally, they are going to make it, the subject is tough. The subject is tough because of this procedure. So first you should get the interest, why you want to study this, how it is going to be helpful. Then we'll get the interest. Then learning is very simple. And to reproduce, we are going to do the by heart. So first part is you are living, and second part you are giving importance. And finally, you are going to say that not only this part and any subject you are going to say is a tough, tough, tough. Now come to the topic. Here, to understand this angle of arrival, in which direction it is coming, we are going to use the frequently the matrix algebra. So we should know that the fundamentals of matrix algebra, how to represent the signals in the matrix form and all these things. Multiplication, addition, subtraction, inverse, many operations, identity, diagonal matrix, all these concepts. How to find the determinant and all these things. So you have to recollect it once again quickly. The fundamentals of matrix algebra. Go through the lower standard, maybe 10 plus 2 or in the 10th standard, and get all the formulas once again quickly. Then it will help you a lot while writing the code. Then array correlation matrix, how to correlate it. All these things we are going to see that. And it is very useful. As many have completed the assignment, you know that how to represent the signal in a matrix form and how to processing that signal. So now we are going to see that. Then at the end of this unit, the boy is able to answer these following things. Here boy means not only the boy, the girls also, all the students. So at the end of the sections, you are able to answer all these things. If you are unable to answer, then attending my class is useless. And not only that, you are not showing any interest and you are not doing any efforts from your side. And you are blaming to the teacher or blaming to somebody. Network is not good, or the system is not good, or parents are not supporting, or teachers are not explained, and somehow you are satisfying your ego and blaming to others. At this stage, blaming to others is not at all correct. You have to learn whether it is discussed or not, whether the network is there or not, whether the material is there or not, whether the parents are supporting or not. Somehow you have to solve all these problems. Based on that problem, you have to find the solutions and you have to go ahead further. You are maybe poor. Try to use your friendship. Many friends are very sound at financially. Then you have to take the help from them. And after that, getting job, you can pay back to them. Whether really you are a good friend. And you don't need to financial support. Then you need some understanding. You interact with the friends and the teachers and get the information. That is your duty. So you have to work hard based on the problem and solve the situation. And no need to blame to the others. No need to blame to the others. It is not correct at this stage. Try to understand that. You are not a small boy or a small kid. So at the end of the class, you are going to answer Bertelt AOA estimation, Capon AOA estimation, angle of arrival estimation, a linear prediction estimation, maximum entropy method, harmonic decomposition method, a minimum norm angle of arrival estimation, a music estimation. Is a music means multiple signal classification, then spread. So like this different methods we are going to see. So n number of methods are there in the literature. It is not possible to learn all the things within the time. So based on the availability of the time, we are taken with the few important algorithms or the methods to find the angle of arrival or to estimate the angle of arrival in which direction signals are coming. Bartlett, Capon, maximum entropy, harmonic decomposition, minimum norm, music, and split. So very, very important. And not only in the smart antennas, these techniques can be used in the signals and systems, in a communication, in some other fields also people are using these techniques, slight modifications of that. Then this angle of arrival estimation can be, or you can see in the different textbooks with the different terminologies. You need not worry about that. So AOA estimation has also been known as spectral estimation, direction of arrival, in a short form DOA estimation and bearing estimation. Spectral estimation, direction of arrival and bearing estimation. Slight difference will be there among them, but as a whole you can say all are same as angle of arrival. In some books they are going to write direction of arrival, some books they are going to the spectral estimation and all. Especially in signal system and in a, what do you call it, in a DSP subject, they are going to call it as the advanced DSP, the spectral estimation. Under that heading, they are going to study all these concepts. In a communication, we are going to see it generally AOA or a DOA. And bearing estimation. Especially these are going to be used in acoustic, then sonar, and in radar applications. There they are going to use this terminologies. So more or less all are same. So you should not confuse whenever you are referring different textbooks in this domain. In some books, they are going to use. Hello, voice is clear? Is it audible?
Yes, sir.
Hello,
Yes, sir.
right, right. Because I'm getting frequently calls from your classmates. Okay, fine, it's good. So if you are unable to access, log out and again log in. Because now it is very clear, maybe problem at your side. Right. So we have a spectral estimation, direction of arrival or bearing estimation. In the radar applications, people are going to use the terminology DOA. In acoustic and sonar applications, they are going to use the bearing estimation. In advanced signal processing, they are going to use the terminology spectral estimation. But as a whole, we are going to estimate the signal. How we are going to estimate it? From the terminology itself, we can understand easily. We have so many signals, a collection of the signals. We are going to collect so many signals and we are going to estimate it based on the power levels. You have to examine in the time domain or in the frequency domain. Normally people are going to use the time domain, and in some textbooks they are going to analyze these concepts in a frequency domain also. You need not worry about that. X of t or x of omega, doesn't matter. Then you have to estimate all the signals based on the power levels. Before going to learn these things, we are using these concepts AOA. I gave in the beginning an example. You are in the class and you are assume that you are facing in opposite direction of the blackboard. And for time being you are a blind. Even then, you are going to turn your head towards the blackboard. How? You are going to examine. You are going to collect the signals in all the directions, and in which direction signal strength is more, then accordingly you are going to turn your body completely towards that. So you are going to receive the signals in all the directions. You will receive the signals from the teacher, from your neighbors, from your classmates, from the black bench, all other directions, noises, and signals from the corridor. Many signals you are receiving. But why you turned your head towards the blackboard? Because you are receiving after collection of all the signals, you are analyzing, you are processing each and every signal strengths and in which direction it is coming. Then based on that you are going to face the overhead. Then you may ask, sir, I'm seeing the ends, I'm facing you towards your teacher. For time being, close your eyes. Then you are in the opposite direction, say, or some another angle. Then lecture is going on. automatically you are going to turn to the correct position. You are going to face in the correct direction. How it is possible? You are received all the signals and you are going to recognize, oh, this is the fan sound, this is the my friend signal, this is a backbench student is calling, and this signal is from the corridor, and this is my teacher's voice. And you are going to find out the spectral components, and accordingly you are going to adjust your neurons, and it will give the signal to turn the body, and you are turning. The same thing you are doing here. See, that's what I'm telling. Not only this subject, any subject is everything is existing in the nature, but we are unable to find the simplest and easiest examples for the subject, technical subject. And finally, you are going to think that this is different, that is different, and finally, you are struggling a lot. If you look at in that fashion, then getting solutions that problems are very simple. You are going to use the beamforming techniques in the on the dais. You can see that they are going to place n number of sensors, microphones. So nowadays, it's very small units, and of the dais you can't see that, but it is there. They are going to place at different places with different locations to capture the signal from the speakers or those who are going to perform on the dais. You can see that they are not going to place all the uh, instruments at one place. One at east, one at is north, one at south, or at the different angles. Finally, they are going to capture the signal, and they are going to use the beamforming concepts. Then finally, we'll get the nice audio effect on the auditorium or some places. How it is possible? Again, there also is a beamforming. Here also we are doing the same thing, but it's slightly different, little bit. So what I'm going to say that you have to observe the surroundings thoroughly. Then understanding subject is very easy. Any subject. I'm repeating twice, thrice, because I've seen n number of times many students are struggling a lot with this only. Most of the teachers, they are not taking care. They will come and they will explain spectral estimation. Take this formula, x of t is equal to xt plus n of t, and do that, this, finally over. But what is use of that? It is there in the textbook also. If you spend 1 more hour, then you will get the concept. If the teacher is there, means it is easy to understand for 10 minutes. If the absent, we are absent the class, then you have to struggle a little bit more. That's the only difference. But how long that you are going to keep that concept? Quite a longer period? No. You are going to forget immediately because you understand only that part and you don't know the importance and significance, and finally you will forget easily. And every time you have to rebrush, and it is a burden. If you analyze the subject in a thoroughly in application point of view and with the day-to-day applications and surroundings and all, and it is easy to remember, and you can get the subject and you can love the subject. You have to reach that level. You have to reach that level. So you have to collect all the signals. You know, all the sensors are going to collecting. So after receiving all the signals, you have to process it. Then you have to estimate in which direction signal is coming. For that, in the previous slide, we have the different techniques. With that, we are going to harmonic decomposition, maximum entropy. You studied entropy concepts in a information theory. Similarly, also you have the entropy concepts. Then we are going to estimate it with a linear prediction. Then minimum norm we are going to do, and we are going to classify all the signals. With that, we are going to do estimation. Anyhow, one by one we are going to see all the methods in the coming slides. Then, so to understand these estimation concepts and all, and to write the programming, we, boy should have the command on fundamentals of matrix algebra. Column vector, row vector, vector transpose, vector Hermitian transpose, all these things you should know that. How to multiply, how to subtract, uh, how to get the determinant, inverse, all these things. Just I have mentioned few important notations or operations. So here we are going to get the signals. We know that you are going to get the signals. What are the signals you are going to receive? Say I have a n signals. You have n signals. You are going to receive the n signals. Assume that your network may be like this, your system, and you have the weights, recollect the beamforming structure. And you have the summer, summation, then the output, y of t. That's all. And you have the W1, W2, and so on, and WM, M weights. So for time being, M may be 10, you have 10 elements, 1, 2, 3. So it means that you have the 10 antennas, sensors, you can call them. In different books, they are using different terminology, don't worry. So you have the 10 elements, antenna array consisting of 10 elements. Then again, it is a broadside array, unfair array, all these things you have studied. And the spacing between also, you know that is a lambda by 2 or lambda by 4 or some based on the application, you have to do that. And you are going to receive the signals. One signal, then another signal, then another signal. So like that you are going to receive. How many signals are there? N signals. So S1, S2, and so on, Sn. So it means that, say, for example, 5 signals for time being. What do you mean that? Your first element, antenna 1, your T1, transmitter or a receiver, whatever. So for example, antenna 1 or the sensor 1, the T1, element 1, element 2, T2, and so on, T10, antenna 10, AT, antenna 1, AT2, second element, then antenna 10. So you have the 10 elements. This first element is going to receive all the signals S1, S2, S3, and S5. Are you going to receive all the signals at a time with the same phase, with the same magnitude? No. It try to recollect it once again, all the concepts. One signal will come first, other signals maybe with the different phases will come. So you have to draw the wavefront. So you know with the delays you are going to receive, and you try to express the signal. So you are going to receive S of t into e power j omega t. Omega t. So I can say it is S1 of t. The plus, and like that you can get the all the signals. So here we are going to receive all the signals with some delay. Similarly, S S2 of t, and so on. And with the e power some, this is some delay and all. So you are going to receive all the signals with the different phases, with the different magnitudes. Then you are going to multiply. So this I'm going to call it as a signal x1. Then here x2. Here x generalized form xm. So we can get the formula quickly. Xm of t is equal to m may be 1 to 10. Xm of t is equal to, then we have the signals plus noises also. Here I am not mentioned in the noise. So you have to consider the noise is also into account. Then you will get the signal. And that signal is processed or is multiplied by W1. Similarly, this is W2 and this branch is multiplied by Wm. And finally, you are going to add up and we will get the Y of t. This already was in the previous classes. So now you have to examine all these signal components. What are the power levels? And from that, we can get the in which direction signal is coming. We can estimate it. So in that process, we need to represent all the signals in a vector form. So whenever if we refer any textbook, if we have a small a bar is a vector. Say for example, the steering vector. Then a bar is equal to a0, then a1 bar plus a2 bar and so on. These are the elements for the steering vector and we are going to represent it as a bar steering vector. And the same I can represent in a matrix form. Then I'm going to use, I will use the different color. Capital A bar. Capital A bar. Whenever if I'm going to use the capital A bar, then your signals are represented as in a matrix form. In a matrix form. So that you should know that before going to see these notations. Small a bar is the signal vector notation, signal vector notations. Capital A bar is represents signals values in a matrix form. There's a difference. The other one is vector, the other one is a matrix notation. Then we have a column vector. You know that. You studied a number. So I can say A is equal to, A is a matrix is equal to, I have elements maybe like this. I have elements like this. Are you got the point or not? 1, 2, say 5. Some values. Then I can say it is a my column vector. Only one column and many rows. Similarly, row. If we take the transpose, then it is a row vector. So we have only one row and many columns. And we can have a transpose. Rows becomes columns, columns becomes rows. Hermitian transpose. You have to apply a transpose and not only that is consecutive. Consecutive of that. Are you got the point or not? So Hermitian or Hermitian. Vector Hermitian transpose is you have to transpose. Transpose means you have to write like this. A is a vector, a matrix, and on the above you write T. So this is a transpose. And you can use the star. This is a transpose. But a Hermitian transpose means A bar, and H. On above we can write H. This is the notation for Hermitian. Hermitian means consecutive transpose. You have to apply consecutive, then transpose, or transpose and consecutive. So recollect all these things, multiplication properties and all, multiplication properties and all. then, then vector dot product is nothing but inner product, A into B. And you know that when you are writing, so you have to satisfy the first matrix column number is equivalent to the rows of the second matrix. Then you can do the product operation. So A into B, the columns of A number should be matched with the rows of the B matrix. Then only it is possible. So recollect all the matrix multiplications and all these things and do the inner product. When you are multiplying, then it is called as inner product. Then Vandermonde vector is nothing but a column matrix. Nothing but a column matrix. So normally you are going to see most of the names column vectors or column matrix. Those are called as a Vandermonde vectors. Frequently you are going to see you are going to represent the signals in the Vandermonde matrix form. Then matrix basics. What do you mean by matrix? You know that is a collection of the elements of that event or that process and all. So we are going to represent all this collection of elements in the matrix form as an M by N. So a matrix is an M by N collection of elements. Collection of elements. Then you have to find the determinant. Most of the times we need these operations: addition, multiplication, identity matrix, Cartesian basic vectors, then trace of the matrix, then matrix transpose, Hermitian transpose, inverse of the matrix, and we need to sometimes add the diagonal elements, and we have to find the norm. Then we have to find the eigenvalues. Means eigenvalues is nothing but approximation, the closeness of the that that operation. So you have to estimate it. You have to approximate it, the values of that processing. So the eigenvalues you have to find, or the eigenvectors of the matrix, all these things you have. You can recollect it. You may be studied. You might be studied in a 10th or 10 plus 2 castic equation. Lambda I minus A into something is equal to 0 and all. So we will get the some castic equation. And if we solve it, we will get the eigenvalues. It means or the approximate to the your equation or your process. So here we frequently are going to use these eigenvalues and eigenvectors of the your signals. And with the help of that, we are going to estimate the power and all. Then we can estimate the which direction, in which direction signal is coming. So it's very important, this matrix basics. Otherwise, it's very difficult to uh, complete the code. You have to be very careful. You have to be very careful. And most of the times, students will think that, okay, what is their matrix? It's very simple. We know that we can do. But if you are not going to brush up once again these fundamentals, then during the exam time, we will be confused and we will lose the marks. So you have to brush up. This is the prerequisite course. I'm not going to take the much. Just I give the importance of this topic. So go through that in the free time and get all the concepts, all the operations and all the what are the properties are existing in the matrix operations. How to convert it into identity matrix, or how to find the determinant, norm, addition, subtraction, all these things. See, you can see if you have a rows or columns are same, then your determinant is 0. If you don't know this property, and if you do that, it takes time and is a wastage of the time. So that is why you have to recollect it the properties once again quickly. So just I gave the one point importance of that. So it's very important. You have to recollect it. Then how to represent in the signals in the MATLAB? How to get it? Already those who are completed the assignment, they know that how to represent and all. Anyhow, I'm going to show you once again quickly. So matrix A is equal to say 1, 1 comma 2 comma 3 comma 4. You can type it. Then we will get like this. And you can mention another one, B, another matrix B. Or you can find the det of A. Sorry, it should be capital. Uh, Det of A. Why? What is happened? Should get it. Where I did mistake.
Sir, determinant is only defined for square matrices.
Yeah,
Not
this
for
I did. Oh, is the 1/4 I gave. Sorry. Oh,
so it's
yeah, yeah.
4 less
So
1.
like that, I like that. See, you have to be very careful. Then writing code is very simple. Otherwise, we'll do the mistakes. So with the overconfidence, if you start like this, will be happening. So we'll waste the most of the time is going to be wasted. So you have to recollect it all these things, and you can do that. Are you got the point or not? So you can give that. So A is equal to 1, 2, 10, 3, 4. Now it is a 2 by 2 matrix. Then you can type it whose. Now it is a square matrix. Then you can write det of A. Sorry, det of A. So you'll get the answer. So for this problem, -2. So we can like that. Once we know how to write the code and all, we can use the built-in functions, and you can save the time. Otherwise, you have to write the code. Then is a time waste. So you should know what are the functions are available, how to write and all. Just I gave only one. Otherwise, if you don't know what is the syntax for the determinant, then you have to write the code. It takes much time. Similarly, eigenvalues. So you can get the eigen vectors and all. So it's very simple. We have the 2, 3 equations, the syntax. With that, you can do that. So you should be very familiar how to handle the matrices on a MATLAB. Then it is easy. Then it is easy. So before going to close, any doubts? So everyone has to go through the once again MATLAB operations, how to use the MATLAB commands to represent the matrix operations, so that it is easy to write the code for the for AOA estimation. So next class onwards, we are going to see different estimations. Today is just introduction and motivating and making awareness and uh, getting interest. For that only today's section. Okay. Any doubts till this point? And I have seen many are submitted the assignments. Many are very few are to be submitted to submit. Almost 90% of the students were submitted, but they have not followed the instructions very clearly. See, you have to write your roll number .m, and so if people are saying, sir, roll number is not accepting, you write the name followed by a .m, like say for example your name is Krishna, K, roll number 94253 .m, like that you can do. I have just now I have typed. So use the your starting alphabet and followed by roll number. Are you got the point or not? So, and do that, and complete the assignment, and write the how you implemented the algorithms on a Word file, and you submit everything in a Google Classmate link. Already I circulated the Google Class link, Google Class. There only how to submit. Many are submitting by mail to me, to my aprao@nidw.ac.in. It is not correct. See, you should follow the instructions. So those who are submitted by mail, once again submit in the Google Classmate link once again, because I'm going to consider that link only. I'm going to open and I will evaluate there only. So if you submit it in what do you call, in by mail, it is very difficult to identify and check it. Is it clear? So because all files I can see there only easily. In the mails, one fellow is today, another fellow is some another day, and tracing, identifying, and it is not that much easy to do that. You know that daily we are going to receive n number of mails, wanted and unwanted and all, and there also again I have to identify which one is the desired one and undesired mails and all, and discarding is not that much easy. Is it clear? Uh, so any doubts? So those who are noted completed submission of the assignments, try to complete within this week. And those who are submitted by mail, they have to complete once again, and they have to post in the Google Class link. Any other doubts? Please respond before going to close.
No, sir.
Okay, good. So I hope that you wrote exams well. Say yes or
Sir,
no.
most of it was from syllabus. So,
Loudly, clearly. Most of them.
sir, most of it was from syllabus, so it was good.
Yeah, from the syllabus only.
Yes, sir.
See, I used to do that only like that. But only one or two questions I will ask little bit, uh, little bit. Okay, anyhow, good. Right. Have a nice day. So you came to the campus or not?
Sir, like the dates are from 7th of March to 11th of March.
Okay, for your slot is different. Okay,
Yes, sir.
right, right. Have a nice day. We'll see the continuation. The next class, algorithms, estimation techniques. It's a
Thank you,
very
sir.
important subject. Be attentive and learn the concept. Right. Have a nice day.